In this video, I want to talk about the road boundary extraction paper. The author did something wonderful for the self-driving cars, and the purpose of this paper is to find the road boundaries and to direct the cars for safe driving. The old algorithms or the old methods is OpenStreetMaps, which have a good result for the road boundary, but it have errors in meters. So it cannot be used in the self-driving cars because meters will make the driver fall off the road. So the author want to find some algorithm that can find the road boundaries at least in a couple of centimeters for the safe driving. First, he reviewed some old algorithms, but none of them are reviewed in details. But these algorithms use deep learning, and they might cut time consuming, so cannot be used in real time. And one of the oldest algorithms in 70s, this author used an interesting method called a snake that captures the road network. For example, it started somewhere on the road edge, and because road edge are always continuous, so it works like a snake, and to find other the whole road edge. And the author used this method, and also he used the LiDAR and HD camera images. For the LiDAR method, it have a wonderful thing is height of the surfaces, because if we drive on the road, most of the time the road has a curb, and the curb is a little higher than the road. So if we know there's a height difference, we know this is an edge of the road. So the car won't be driven on the curb. And he put everything together, and in this everything in this image. First, he used the LiDAR camera and HD camera, and also a gradient image in the LiDAR. And he put it into a neural network. And after this, it has three outputs. One is a detection map, which detects the edges. And the other one is the endpoint. And the detection map marks the closest point to the edge at white, and the further it goes, the darker it goes. So the further it goes to an edge, it more and more further it becomes black. And but this might have some errors in it, because it won't be a straight line, or may have some errors. But he also put the other two layers together. One is the endpoints, which means at this point it is the beginning or ending of the road boundary. And this one is I believe this is the most important map, the direction map. And for each point on the map, it have a vector goes to the nearest road boundary, nearest edge. So from this image, we can see the purple one should go downwards, and so all the purple one, the nearest edge is under it. And for the green ones, it should go right, and the red one goes to left, and the yellow one goes up. So when we find the point here, we also get this vector. So now we know which direction we should go to find the edge. And finally, he used the snake method. He modified it a little bit and called snake. So beginning with one of the endpoints and try to go to the nearest point. And if it goes up a little bit and this vector that goes down, okay, it goes down. And then move to the next pixel. Rotate 90 degrees and move to the next pixel. And repeat this method. Go to the nearest pixel. For example, this time go downward. It's yellow. Okay, yellow. Let's go up. So goes back again and rotate 90 degree. Goes along the road edge. Now, after some iteration, the road edge output is here. And now this map can be used for the safe driving. Okay. And this is the output of the road map. Yeah, here he used some. This is the laser camera. This is a regular camera, and this is a height gradient in the detected by the laser. And the detection map and endpoint and direction map are the output of the first step. And then combine these three images together to get the real road boundaries. So now it's not the outline of the road because here might have some pedestrian walkways. Now the red lines can define where the cars can drive. And the result looks wonderful. Okay, that's it.